So Pji equals to P1i plus P2i plus dot 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 Pni. That equals to, we can write 1 by capital N plus 1 by capital N dot 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 1 by capital N. It's n times. That equals to small n by capital N. Now if u1 comma u2 comma dot dot un are the n units selected in the sample, then the probability of their selection is p u1 u2 dot dot un equals to p u1 p u2 dot dot p un. When the second unit is to be selected, then there are n minus 1 units left to be selected in the sample from the population of capital N minus n units. Similarly, with the third unit is to be selected, then there are n minus 2 units left to be selected in the sample from the population of n minus 2 units. So on, if PUN equals to, it's PU1 equals to small n by capital N, then you can write PU2 equals to n minus 1 and in that way we can write PUN equals to 1 by capital N plus 1. Thus PU1 PU2 U3 dot dot UN equals to n by n, n minus 1 by n minus 1, n minus 2 by n minus 2 dot dot 1 by n minus n plus 1, that equals to n by n. Now SRSWR. When small n units are selected in SRSWR, the total number of possible samples are capital N. The probability of drawing sample is 1 by capital N to the power small n. Alternatively, let ui be the ith unit selected in the sample. This unit can be selected in the sample either at first draw or second draw or nth draw. At any stage, there are always capital N units in the population in case of SRSWR. So the probability of selection ui at any stage is 1 by capital N for all I, and where I equals to 1 to n. Then the probability of selection of n units u1 u2 dot dot un is a sample is, then we can write p u1 u2 dot dot un equals to p u1 p u2 dot dot p un. So that equals to 1 by n dot 1 by n dot dot 1 by n. So equals to 1 by n to the power n. Now the next topic is probability of drawing an unit. SRSWR. Let A denotes an event that a particular unit ui is not selected at the lth draw. The probability selection say jth unit and kth unit draw is selection of uj at kth draw. That's equals to, we can write p a1 a2 dot 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 ak minus 1 ak bar. Now that equals to PA1, PA2 bar A1, PA3, A1, A2, dot 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 P AK minus 1, A1, A2, dot dot AK minus 2. Then P AK bar A1, A2, dot dot AK minus 1. So 1 minus 1 by n, 1 minus 1 by n minus 1, 1 minus 1 by n minus 2, dot dot 1 minus 1 by n minus k plus 2 into 1 by 1 minus k plus 1. That equals to n minus 1 by n, n minus 2 by n minus 1, dot 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 n minus k plus 1 by n minus 2, dot 1 by n minus k plus 1. So that equals to 1 by n. Now second is RSWR. P selection of uj at kth draw, that equals to 1 by capital N. So now estimation of population mean. Let us consider the sample arithmetic mean small y bar equals to 1 by small n summation I equals to 1 to n yi. As an estimator of population mean, capital Y bar equals to 1 by capital N summation I equal to 1 to n yi, and verify y bar is an unbiased estimator of capital Y bar under the two cases. Now SRSWOR. Let T1 equals to summation I equals to 1 to n yi. Then EY bar equals to 1 by n summation I equals to 1 to n yi. Put here capital E, 1 by n E T1, that equals to 1 by n 1 by n summation I equals to 1 to Ti, that equals to 1 by n summation I equals to 1 to n summation I equals to 1 to n yi, where n units are sampled from capital N units by without replacement. Then each unit of the population can occur with the other units selected out of the remaining n minus 1 units. Is the population and each unit occurs in n minus 1 of the n possible samples. So summation I equals to 1 to n to capital N yi. Now EY bar equals to n minus 1 factorial factorial n minus n factorial n factorial yi, that equals to 1 by n summation I equals to 1 to n yi, that equals to capital Y bar. Thus, capital Y bar is an unbiased estimator of capital Y bar. Alternatively, the following approach can be also be adapted to show the unbiased property. Now, E small y bar equals to 1 by n summation I equals to 1 to n e yi, that equals to 1 by n summation I equals to 1 to n summation j equals to 1 to n yj pii, that equals to 1 by n summation I equals to 1 to n summation j equals to 1 to n yi, that equals to 1 by n summation y equals to 1 to n y bar, that equals to y bar. Now SRS WR, E small y bar equals to 1 by n e summation I equals to 1 to n yi, that equals to 1 by n summation I equals to 1 to n e yi, that equals to 1 by n summation I equals to 1 to n p1 dot 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 ynp, that equals to 1 by n summation n y bar, so y bar, where pi equals to 1 by n for all I equals to 1 to dot dot n is the probability of selection of a unit. Thus, y bar is an unbiased estimator of population mean under SRS WR also.